In this last lesson for Homework Packet 4.1, we're going to be taking a look at finding x and y intercepts of the same four function types that we saw in the previous lesson. So you've done x and y intercepts in several different classes, Algebra 1, Geometry, even into middle school you did x and y intercepts. To illustrate and remind ourselves of what they are, we've got a quadratic right here and the parabola graphed from a quadratic. Okay, we know that we have the x-axis and the y-axis, and the key is to identify the locations where the graph that we have drawn here crosses the x-axis, those are the x-intercepts, and then the location where it crosses the y-axis, that's the y-intercept. So I can see on this parabola right here, I've got my x-axis here as well, there's two different locations here and here where my parabola is crossing the x-axis. So I have two x-intercepts. And then additionally, here's the location right here in which my graph crosses the y-axis. In this case, I only have one y-intercept. What you'll notice is that with any function, you're only going to have one y-intercept. You'll never have more than one y-intercept. However, it is possible to have multiple x-intercepts. Now, in order to be able to look at a function and calculate x and y intercepts, we have to remember two fundamental truths. First off, right here as it's written, the x-intercept always occurs when y is 0. If I look at both of these x-intercepts down here, and I were to ask you to give the coordinates of those points, what is the y-coordinate of both of these points? In both cases, in both x-intercepts, the y-coordinate is 0. So where are the x-intercepts? It's when y equals 0. Vice versa, we look at the y-intercept right here, and this statement is going to read, the y-intercept always occurs when x is 0. So if I were to look at this y-intercept over here and have you tell me where the x-coordinate of that point is, you'd say 0, because it's right on the y-axis where x is equal to 0. So keep these two things in mind as we progress to the next slides. The x-intercept always occurs when y is 0. The y-intercept always occurs when x is 0. Let's start with a function that we're used to. We're used to linear equations. You've been doing them for several years now. And we've got a nice simple linear equation here where we want to find the intercepts, the x-intercept and the y-intercept. Here's what you need to remember. Let's start with the x-intercept. If you want to find the x-intercept of any equation, plug 0 in for y, because we saw that the x-intercepts always occur when y is 0. So I'm going to put 0 in for y. That gives me 0 equals 3/4 x minus 12. So to find the x-intercept, plug 0 in for y, and then solve this equation for the value of x. To do that, I'm going to add 12 to both sides. So that's 12 equals 3/4 x. I'm going to undo the divide by 4 by multiplying by 4. So that's a 48 is equal to 3x. Finish it off, I'm going to divide by 3. 48 divided by 3 is 16. So x is equal to 16. This graph crosses the x-axis at x equals 16. Writing that as a coordinate point, we would write it as 16, 0. The y being 0 because that's where our x-intercepts occur. I can do the same thing now with my y-intercept. But in this case, if I want to know my y-intercept, we saw from the previous slide that we always plug 0 in for x. So this is going to end up as y equals 3/4 times 0, plugging 0 in for x, minus 12. So that is y equals, well, anything times 0 is just 0. So that's y equals 0 minus 12. That gives me finally y equals negative 12. As a coordinate point, the y-intercept is at 0, negative 12. And again, the x-coordinate is 0 because my y-intercepts always occur when the x-coordinate is 0. So 0, negative 12. So again, it doesn't matter what function type we're going to look at. We're going to look at 3 other types. The concept is always the same. To find the x-intercept, plug 0 in for y. To find the y-intercept, plug 0 in for x. So let's look at finding intercepts in the context of an exponential equation. Again, to find the x-intercept, we plug 0 in for y. So this becomes 0 equals 3 times 1.4 to the x plus 3 minus 4. So we have an exponential equation where we need to solve for x. I'm going to first start by adding 4 to both sides. That's 4 equals 3 times 1.4 to the x plus 3. And divide both sides by 3. So that's a 1.33 is equal to 1.4 to the x plus 3. Now if we remember, it hasn't been too long since we've solved exponential equations, that at this point we have to convert from exponential form into log form. So we start with the exponent. X plus 3 is equal to the log base 1.4 of 1.33. So now what I need to do is evaluate what the log base 1.4 of 1.33 is. So go to our calculator. We're going to do the log of 1.33 divided by the log of our base value 1.4. And we end up with x plus 3 is equal to 0.85. Last step here is to subtract 3 from both sides. That gives me x is equal to negative 2.15. So the x-coordinate, this graph crosses through the x-axis at the coordinate point negative 2.15, comma 0. So again, to find the x-intercept, we plugged 0 in for y and solved for x. Now to find the y-intercept, we're going to plug 0 in for x. So that's going to be y equals 3 times 1.4 to the 0 plus 3 minus 4. And this is just a simplification. There's nothing to solve because it's already y equals. I just have to make sure I do the correct order of operations. 0 plus 3, right here's 3, so this is really just y equals 3 times 1.4 to the third power minus 4. So I'm going to do 1.4 to the power of 3, and then I'm going to multiply that by 3, and then I'm going to subtract 4. And I end up with a y equals 4.23. Y equals 4.23. So the coordinate at which my y-intercept occurs is at 0, 4.23. 0 in the x-coordinate because my y-intercept occurs when x is 0. So we've got 2 more function types that we want to look at in finding intercepts. And the next one is radical equations. So don't forget, a radical equation is an equation where the variable x is underneath a square root. And that's what we have in this example right here. Y equals 4 times the square root of x plus 2 minus 5. So let's start with the x-intercept. To find the x-intercept, plug 0 in for y. So that's 0 equals 4 times the square root of x plus 2 minus 5. So I've got to solve this for x. I'm going to add 5 to both sides to start off. 5 equals 4 times the square root of x plus 2. And divide both sides by 4. 5 divided by 4 is 1.25. And that equals the square root of x plus 2. So the only thing left on that right-hand side is the square root symbol. So I'm going to undo that square root with a square. Whatever I do to one side, I have to do to the other. So 1.25 squared Okay. Ends up giving us 1.56. So 1.56 is equal to x plus 2. Final step here is to subtract 2 from both sides. So that gives me an x that equals 0 or negative 0.44. So my x-intercept is at the location negative 0.44, comma 0. So don't forget, with solving radicals, and we undo a square root with a square. So keep in mind when you come into a radical equation examples that that is how you undo that radical. How do we find the y-intercept? Well, we plug 0 in for x. So that's going to be y equals 4 times the square root of 0 plus 2, and then a minus 5. So here again is a simple evaluation. 0 plus 2 is 2, but then I have to square root it. So I go to square root of 2, and then I'm going to multiply that by 4, and then I'm going to subtract 5. And I end up with 0.66. So the y-coordinate, or rather the y-intercept now, is at the location 0, because that's what I plugged in for x, and that's where my y-intercepts occur when x is 0, comma 0.66. And there's a location of the x-intercept, or rather the y-intercept. So the last example we want to take a look at is an example of a quadratic equation. So again, let's start with the x-intercept. Find the x-intercept and plug 0 in for y. So 0 equals negative 2 times x minus 4 squared minus 2. So where are the x-intercepts? I have to solve this for x. So I'm going to start by adding 2 to both sides. So that's 2 equals negative 2 times x minus 4 squared. And then I'm going to divide by negative 2. So that gives me a negative 1 is equal to x minus 4 squared. Now we know that we undo a square with a square root. So both sides get square root. But anytime I undo a square with a square root, what does the other side get? It gets a plus and minus sign. So it actually becomes x minus 4 is equal to positive and negative square root of negative 1. Lastly, I'm going to add 4 to both sides. Now I can't add the 4 to the negative 1 because the negative 1's under the square root and the 4 isn't. So it simply becomes x equals 4 plus and minus the square root of negative 1. Now we've got a problem here with finding the x-intercept. But interestingly enough, it ends up not being too big of a problem. It matches exactly what we expect to occur. Sometimes we will get real solutions when we try to find the x-intercepts of a quadratic, because the parabola that's graphed from the quadratic crosses the x-axis 2 times. However, what if the quadratic that we have never crosses the x-axis? It's always above or always below the x-axis. There are no x-intercepts. What occurs then is what we have here. We end up with an imaginary solution. We know there's an imaginary solution because there's a negative under the square root. Well, remember that the square root of negative 1 is I. So x equals 4 plus and minus I. My solution is imaginary, therefore I know that I have no x-intercepts. There are no x-intercepts because when I tried to find them by plugging 0 in for y, I ended up with imaginary solutions, which means that the parabola is either all above or all below the x-axis. It doesn't actually cross the x-axis. However, as I said, we will still always have a y-axis or a y-intercept with a quadratic. So to find the y-intercept, we plug 0 in for x. So that's y equals negative 2 times 0 minus 4 squared minus 2. So 0 minus 4 is negative 4. Negative 4 squared is 16, so that's y equals negative 2 times 16 minus 2. So that gives me y equals, my negative 2 times 16 is negative 32. And then subtract 2 more. So I've got y equals negative 34. So in this case, my y-intercept is at the coordinate point 0, negative 34.